exponential function rules. We have spent a lot of time on a different type of function rule, a linear function rule. A linear function rule is one of the form f of x, or y, equals mx plus b. This linear function rule represents a linear pattern in which I start with some value b, and then I repeatedly add m, plus m, plus m, plus m, plus m. I add m x times, where m is my rate of change. So instead of writing plus m, plus m, plus m, plus m, I represent that repeated addition of my rate of change with multiplication, m times x. So a linear pattern is one in which I have repeated addition, which I represent with multiplication. An exponential function rule is one in which I start with some value, start value of a, and then I repeatedly multiply by my growth factor b, times b, times b, times b, times b, and I multiply by that growth factor x times. Now, just like instead of writing plus m, plus m, plus m, I write m times x, instead of writing times b, times b, times b, I represent this repeated multiplication with a power. So this is where my exponential function rule form comes from. F of x equals a times b to the x power. That power, b to the x, represents my repeated multiplication, times b, times b, times b, x times. So I start with a, it's my start value, and then I multiply by my growth factor b, x times, b to the x power. Let's go ahead and look at an example. I have 3 guppies. It's my guppy. And each month, my guppy population quadruples. So we have some special words. We have double, which means times 2, triple, which means times 3, and then we have quadruple, which means times 4. So quadrupling means I have an exponential function rule, an exponential power, in which I'm repeatedly multiplying by 4. In the beginning, I have 3 guppies. And then each month, the guppy population quadruples. That means after 1 month, I have my original 3 guppies, and then my population quadrupled times 4. Second month, I have that 3 times 4 guppies that I had after the first month, and then that population quadruples, 3 times 4 times 4. After 3 months, I have all the guppies I had after 2 months, 3 times 4 times 4, and then that population quadruples. After the 4th month, I think you're seeing this pattern, 3 times 4 times 4 times 4, and then again I multiply by 4. My population quadruples. This is my expanded form where I'm showing my repeated multiplication. This is a really good way to really understand what an exponential pattern is, repeatedly multiplying by that same value, by that growth factor. My simplified form is instead of writing my repeated multiplication times 4 times 4, I'm going to represent that repeated multiplication with a power. So 3 times 4 times 4 is 3 times 4 squared. 3 times 4 times 4 times 4, I represent that multiplication with 4 cubed, or 4 to the 3rd power. After the 4th month, I have 3 times 4 times 4 times 4 times 4, which is 3 times 4 to the 4th power. For my simplified form, it's not really relevant to month 0 and month 1. I can write this as a power, 3 times 4 to the 1st. That's fine. It's not really necessary though. And then after month 0, I think this is actually not simplified, but I could use a power, 3 times 4 to the 0, because 4 to the 0 is 1. But really the simplified is only really important when I have exponents bigger than 1. My value, the beginning, I still just have 3. My value is actually computing the number that this represents. So 3 times 4 to the 0, 3 times 1 is just 3. After month 1, I have 3 times 4, which is 12. After month 2, I can say 4 squared is 16, 16 times 4 is 48, or I can just do 12 times 4, 48. Now I'm getting out my calculator. 48 times 4, did you figure it out before me? 192. And then times 4 is 768. So to find this value, I could either plug 3 times 4 to the 4th into my calculator, or I could just take my value and repeatedly multiply by 4. My function rule for the guppy situation is going to start with f of x or y equals, and then I need my a, my start value. My start value is 3, and then I am multiplying by my power, my growth factor to the x power, my power of 4 to the x. So one way to represent the function rule is f of x equals 3 dot, meaning multiplication, times 4 to the x. A more sophisticated way to write this is f of x equals 3, and then write the base of that power in parentheses, 4 to the x. Either of these is fine with me. So a times b to the x, a times b to the x, where my start value a is 3, and then my growth factor b is 4. Let's look at some other examples. Your math teacher has assigned you one homework assignment. So start value of 1. How nice of me. The number of assignments doubles each day. So doubles is a growth factor of 2. So x is days, f of x is number of assignments. My number of assignments is f of x equals 1 times, so start value of 1 times 2 to the x power, growth factor to the x power. I can write that instead as f of x equals 1, parentheses 2 to the x. Can you see the third way I could write this? So 1 times 2 to the x could just be, when my start value is 1, I can just write f of x equals 2 to the x. So if you see a power without a start value, it has an invisible start value of 1. Last example, your video on TikTok has 12 likes, start value of 12. The number of likes increases by a factor of 7 each minute. So when I don't have a special word like double, triple, quadruple, I'm going to say by a factor of. That represents repeated multiplication by 7, a growth factor of 7. So now here is my function rule. F of x equals 12 times 7 to the x, or a little more sophisticated, f of x equals 12 parentheses 7 to the x power.